Today we're going to practice identifying terms. Identifying terms. So we have learned about combining like terms and the distributive property. And what I'm noticing is sometimes it's tricky to identify the different terms in an algebraic expression.
Oh, so there's not much writing in this.
So an algebraic equation is made up of two expressions. So if I had an equation like 2x plus 5 equals 7x minus 3, here's one expression, and here's another expression. Right? 1, 2. And those are separated by an equal sign. So I have two expressions. That makes up an equation. Equations are what we solve in algebra. Right? Also, equations can be what we graph in algebra. So equations have an equals. Equation equals. Equation equals. Equations are what we solve and graph. Expressions cannot be solved and they cannot be graphed alone. But we do sometimes need to practice simplifying them. So expressions, and this basically means no equals sign. Cannot be solved or graphed. They can be simplified. Sometimes. So if I had an expression like this, 3x plus 2 plus 1, that's an expression in algebra because there's no equal sign. I can't solve that. I can't say x equals 2 at the end of this because there's no equal sign to begin with. I also can't graph it. There's no way I could put that up on a graph and show you what line it makes because there's no equal sign. I couldn't even put it on a number line to graph it. So what I can do is I can look at this expression and try to combine different parts of it. In this case, what I'm seeing is I can combine 2 plus 1 to make 3. And so simplifying this expression would mean 3x plus 2 plus 1 is 3. So all we're really doing here is we're taking our 2 and our 1 and combining them to make a 3.
And that would be the answer?
Yeah, this would be our answer if I asked you to simplify this expression.
Are you asking us to simplify it?
I just did it for you. So, in order to really understand how to simplify things, you have to be able to identify terms. Terms in an expression are separated by addition, and I'm going to say or subtraction in parentheses, and you'll see why I put that in parentheses. So, in other words, if I had a really long expression, 5x plus 3 plus 7x plus 2 plus 3 plus 4x plus 1. This expression, why is it an expression?
Because there's no equal sign.
There's no equal sign. It's made up of 1, 2, 3, 4, 5, 6, 7 terms. Okay? This has 7 terms in it. But a lot of these terms can be combined.
Oh yeah.
And this is where the commutative property of addition comes into play in algebra. So what I'm going to notice, this is a term and it's added to this term. But I can't actually add 5x to 3. There's no way. This means x plus x plus x plus x plus x. If I add 3 to that, it's meaningless, right? All I would be able to do is just plus 3. But I can add these 5x's to these 7x's over here. So I could add 5x to 7x and get 12x. And we talked about that last week. What I want to practice now is just identifying our terms. So 5x is one term. 3 is a separate term. And we know that because they're separated by a plus sign. Now if I had 5x minus 3, let's say plus 2 plus 6 plus 3x plus 4. This is similar. I have 1, 2, 3, 4, 5, 6 terms here. But what I want to point out is that this term here is negative. In this expression, I have 0 terms that are negative. They're all positive. In this one, my negative 3 is really saying plus negative 3. So this term itself is negative. Which means when I move that around, the negative is going to stay with the 3. Okay? My negative is a part of this term. So as we're identifying terms in this expression, I would say one term is negative 3. Let's look at the first one. Can you name all of the terms in this expression? We have 5x.
Yeah, I can.
That's one term. What's the second term?
7x.
Second term is 3.
Really? Oh, okay.
What's the third term?
7.
7x.
X. 7x.
What's the fourth term?
2.
2. What's the fifth term?
3.
What's the sixth term?
4x.
4x. And what's the
Plus
seventh
one.
term? 1. This term is just 1. In this expression, what are my terms? I have
5x minus 3.
negative 3.
Oh, negative
Okay?
3.
Negative 3 is the term. So I have 5x, negative 3,
Plus 2.
no, 2, 6,
3x,
3x, and 4. And we could say positive 2, but plus 2 is not the term. The term is 2 or positive 2. It's separated from this term by a plus sign. But it's over here, it's separate. Okay, I want to kind of play around with ordering these terms a little bit. So I'm going to just write a bunch of terms on the board. 3x, 4x, 5, 7x, 9, negative 4x. I want you to write an expression that uses all of these terms.
Okay.
In your notes. Write an expression in your notes that uses all of these terms. Remember, this is a negative 2. I'm going to write that a little closer. All right, do you want to give me your expression?
Sure.
Okay.
4x. I don't know if it'll work, but 4x plus 3x. Negative 2.
So minus 2?
Yeah, minus 2. Oh, that's a minus. Oh, okay, minus 2.
Yeah.
Minus 4x. Plus 9. Plus 7x. And last but not least, plus 5.
Let's see if you did it. Do you guys see the 3x term? You see the negative 2 term?
Yeah.
Well, not actually, we don't actually see negative 2, right? But what we do see here is minus 2, which is the same thing as plus negative 2. Right? So this term is here. It's just a little bit hidden. Plus negative 2 turns into minus 2. Okay? Do you see the negative 4x term?
Yeah.
Yeah, right here. And again, we made it into a minus 4x rather than a plus negative 4x. But that's okay. Does everyone see the 9 term?
Yep.
7x term?
Yep.
5 term?
Yep.
4x term? 3x term?
Yeah, I see all of them.
Okay. We see all of them. Good job.
You're welcome.
So look, we have 1, 2, 3, 4, 5, 6, 7 terms. And we had 1, 2, 3, 4, 5, 6, 7 terms up here. How many of those terms are negative?
1, 2, 2.
2 of them are negative. Does anyone else want to give us their expression?
I will.
What's
Wait,
your
does mine
expression?
work?
Okay, 9 plus negative 4 x plus 3x plus 5 minus 7x plus negative 2. Hold on. Okay, wait. In between the 3x and the plus 5 would be 4x. Because I thought I repeated something.
Okay. So I see one thing about this that does not match these terms. Does anyone else see it?
The plus.
So we've got our 9. We've got your negative 4x. You've got your 3x. You've got your 4x. You've got your 5. You've got a negative 2. What about this term, though? Where did this one come from?
The bottom.
Okay, this is a 7x term here. How did you put it into your expression? You put it as a negative. So that would be a negative 7x term.
Minus 7x.
So you could put minus a negative 7x to make that correct, or you could just put plus 7x. So I want you to fix that in your notes. That would have to be a plus in order for that to have these exact same terms.
Is this going to be our homework? Turning
No, not exactly.
Okay.
We will be practicing this
Was mine
this
right?
week. We went over yours.
Was it good?
Does anyone else want to share theirs? No? Okay. 2 examples is good.
Was it good?
So now I want to go in the other direction. I'm going to write an expression on the board. I want you guys to write a circle or a list of all the terms. So here's your expression. 8x plus 9. Okay. Go ahead and list all the terms in there.
I'm going to just write that out.
Oh, we're gonna list those?
Just list them. Put them in a circle or a list or whatever.
So this isn't gonna be on our homework?
Your homework will be related to this. I'll show you. is going to be a really exciting part of the video. Me just standing here. All right, what are the terms that we have in this expression? Go ahead and list them.
8x. 9.
Negative 6x. 3. 2. Negative 4, 7, and 8. Wait, no, we got it.
7.
So I heard someone say negative 4. Is that one of the terms here?
Negative 4x.
Negative 4x.
Yeah.
So we have to include
Yeah.
this entire thing.
Yeah.
Right? That entire thing is our term. Okay. So you can list out the terms, you can make an expression from terms. Now the next step is to actually simplify something like this. So can we combine
Yes.
our like terms? Like terms, what is the definition of like terms? It means terms that have the same variable and exponent. And you don't have to worry about the exponent part right now. So just terms that have the same variable. So what would be all of our like terms? In this expression, we have two types. We're going to have our x terms, like 8x, and we're going to have our constant terms. So make a list of the x terms and make a list of the constant terms. In our x terms list, we would have 8x, we would have negative 6x, we would have negative 4x. And in our constants list, we would have 9, 3, 2, and 7. Okay. So we're going to combine our like terms now. Now to combine them, all we're really doing is using the commutative property. We're saying 8x minus 6x minus 4x, which would be 8x minus 6x is negative 2x. No, it's not. It's positive 2x. Minus 4x is negative 2x. And then we would add all these together. 9 plus 3 plus 2 plus 7, which is 21. And so our final expression is just going to have two terms now. Negative 2x plus 21. And in that expression, it has the same value as this. These are equivalent expressions. They equal each other. But this one has all of its like terms combined. Now, doesn't this seem a whole lot easier to work with than all of this?
Yeah. Definitely.
We just have two terms, whereas before we had 1, 2, 3, 4, 5, 6, 7 terms. So this is going to be a lot easier to work with. Yeah.
Can I go to the bathroom?
Can you wait 2 minutes?
Yeah.
Thank you.
With that, okay. Got it.
All right. Let me give you a couple more practice, a little bit more practice with this. All right? Practice combining like terms. So what if I had this expression, 3x plus 4 plus 2x plus 1. Combine the like terms in that expression.
Oh, so
Combine the like terms.
Please answers.
Now, one strategy for doing this
We have to find the answer.
One strategy for doing this is you circle all of the terms that have x's, and then you box all of the terms that are constants.
I found the answer.
So in this case, I have 3x and 2x. How many x's do I have? What's the coefficient on my x term? 3x plus 2x is going to be, and then I have a 4 and a 1, which is
plus 5.
plus 5. So my final expression my simplified expression is 5x plus 5.
Yep, that's what I got.
Cool. So it's really important that we can identify the terms. They're separated by plus signs, right, before we can actually combine
Is
them.
that literally
So-
all?
If you had 7x minus 3 plus 2x plus 8, combine the like terms in that expression.
7x plus 2x.
Okay, 7x plus 2x is
9.
it 9?
9x. 7, 8, 9.
Is that a negative 2?
But just 9?
9x.
9x.
Sorry.
Okay, this is a plus 2. Sorry, I kind of. And then I have an 8 and a negative 3, which is going to be, I would write it like this.
5.
8 minus 3,
5.
which is a positive 5.
8.
9x
4.
plus 5 is our final simplified equivalent expression. So that would be the answer if I asked you to simplify this, or if I asked you to combine them.
Okay, now can I go to the bathroom? In 2 minutes. I'm dying.
I have one more thing to show you.
Oh my god, Nate, I'm dying.
What if I have this? 3 times 2x plus 1. Now, the key, this is why we talked about the distributive property. Think about what I said. Terms are separated by plus signs. But look at this. Nothing is separated by a plus sign here. There is a plus sign, but it doesn't separate anything, because over here I have this, which this doesn't make any sense alone. 3 parentheses 2x? That doesn't make any sense alone. And neither does this. 1 closed parentheses? So these are not my terms, because this can't be a term all by itself. When I have parentheses like this whole thing is one term. So in order to turn it into 2 terms, I have to do my distributive property with the number that's right in front of those parentheses. So 3 times 2x
6x
is
plus 3.
6x, 3 times 1 is 3. Now I have 2 terms.
That's great, Nate.
So the 6x is a term and the 3 is a term, and those terms now make sense.
Yeah, they do.
All right.
Can I go to the bathroom?
Go ahead.
Can I go?